Right, so I have been this week quite busy. Been quite busy because I ended up with 3 pallet loads of faulty in air quotes there, amplifiers off of eBay. Now, first pallet, which was those Gemini amps, which have been in the previous couple of videos. Most of them were faulty, 1 or 2 of them do appear to be working. Excuse me, I've had a wicked chest infection. I've been hacking some right nice stuff up the last couple of weeks. So anyway, the 100 volt line amps, at present, been working on them, got loads I've been slowly going through. I've only actually found, taking them apart so far, before I got to this one which had actually failed. Excuse me a second. So yeah, I had 4 of them or 5 of them. The one I took apart, very basic. It's just like a little SA999 or whatever it is. IC is the output. It's running in bridge mode, feeding the output transformer for the 100 volt line. All internally shorted. Ordered some of them off China. They was like £1 a chip. I've not bothered taking the tops off the other ones. I figured they're probably all the same, but it might not be. So with this 100 volt line stuff, so you can see there's a lot of connections on the back of one of these amps, and settings, priority settings, mutes and all manner of stuff. And people who are buying them, it's people who aren't engineers and stuff. You know, you might have ended up with a doctor's surgery or leisure complex or something. People aren't used to setting up audio gear like this, and you can tell by the settings they've had it on, they've not known what they're doing. So yeah, the last one I just tested, you know, it had like multiple inputs. It had a priority on it and mute functions, and they had the input they were using, which they had the gain turned right up on. They had the mute set on, and the little note that was on top of the amp said no output. Well, it's outputting just fine, it's working just fine. Nearly all of them have been just fine. This is the first one, apart from that cheapy little one. Those other ones were like little, like 30 watt ones. This one's a bit more formidable. This is a proper piece of kit, this one. 4 zone, so it's got 4 separate outputs. It'll output direct to 4 or 8 ohm speakers, then output on 25, 70 volt or 100 volt line system. However, the note on this one said keeps blowing the fuse, and sure enough, fuses blow. So I just thought I'd bring you along for the teardown, and we'll all have a look inside at the same time, shall we? So this might take a while. I should have probably got the electric drill out, but yeah, you know. So, if you don't know what a 100 volt line is, it sounds a bit lethal, doesn't it, sending 100 volts out? Well, it's worked out around some nominal power figure. I've never looked up what it is, but basically it says that if there was 100 volts on the wiring going out of the amplifier, that, that looks like it has to come off, that you then connect certain speakers to it, but they all have a matching transformer on them. So instead of the speakers you connect being rated as an impedance, they might also be a 4 ohm impedance, and the matching transformer, depending on the power rating of the speaker, what it can handle, the transformer's going to have a different turns ratio, and then the impedance of that will be reflected back to the amplifier. And so what they do, rather than giving you an impedance figure, if you buy a 100 volt line amplifier that will output 100 watts, if it's rated at 100 watts, then it's probably turn this around, it'd be easy, wouldn't it? As you can see what I'm doing as well. So if it was rated at 100 watts, basically, rather than having to work out all the impedances of what the amp can actually run directly at 100 ohms, you basically just buy your speakers, and they'll be rated at a wattage rating, and the maths has already been done for you. So all you need to know is that if your amp is rated on the 100 volt output at 100 watts, you could either run 10 speakers all in parallel off of it that are rated for 10 watts, or 2 speakers rated at 50 watts, or 1 speaker rated at 100 watts. Basically, all you have to work out is the power output of your amplifier, and the load is worked out by the sum total of the power requirements of all the speakers of what they're rated for as maximum power. So yeah, it's done basically, it allows you to do large runs of, there's some there. It allows you to do large runs of cable over distance without having to start suffering resistive losses and having to use big heavy cable. You can use quite thin cable with just a good insulation on it. And it also means, rather than trying to do lots of remote standalone amplifiers direct to a speaker where you're having to run power to them all, you just have one central block. You don't have to run power all around. It also means all the settings are on here, so you know, you start putting amplifiers all around the place, people can indiscriminately fiddle with them. But it's also quite a handy system because you can use like L pads or resistive attenuators or variable tapped transformers to match the speakers, and basically you can run your amp. You've got your source going into it, you basically run your amp so it's near flat out, near clipping but not clipping. We never want clipping. And if say it's a small factory or something, there's multiple speakers dashed around it, the workstations, or you know, swimming pool, and you know, just some background music, whatever. The person who's actually by that speaker can adjust their volume, their speaker end, rather than having to keep getting to you to adjust the entire system volume. Or even if it's, say, even if like you know, you could be running 5 speakers on each zone. So if you had that case, if you wanted to, someone wanted their speaker turning down, you'd have to turn them all down. Or likewise, even if you only have 1 speaker on each zone, it means they don't have to go to the main office to the main distribution point where the amp is and turn it down. They can just do it there. And so it's a very handy system. There's different voltages. So this one's got 100 volt, 75 volt, 25 volt. Same principle, just at different voltages. Low voltage, higher current. Excuse me, I need to blow my nose again. So, let's see what's inside, shall we? Look at that. Oi, behave you. Hang on. It's been a bugger. Oh yeah. Isn't that a thing of beauty? So, each one of these is an output transformer, just like a valve amp. You can get dedicated integrated circuits that will run 100 volt line direct, but of course they're no good for low impedance loads. Yeah, you just don't get the robustness and isolation you get with an output transformer. Each one of these outputs is isolated, they're not referenced to a common 0 volt, so it's just, you know, it allows you to have isolated loads. If something happens on one, it can't feed to the others. You know, that can be where some of the problems arise if people are connecting the transformers up. If you connect the 100 volt feed to one transformer to zone 1 and say it's 0 volt to zone 2, it won't work. So what else have we got in here that we can actually see off the top? Tell you what, let me move you to get a better picture. This does not make life easy for me trying to film this, but no point filming it if you can't see what I'm filming. So we've got toroidal power transformer. You generally find on these 100 volt line amps, some are 12 volt, but most of them run at 24 volts. And the reason for that being, I don't know if this one has that on as an option, but most of them have a, yeah, this doesn't appear to have it. Most of them actually have a direct 24 volt in, which feeds into the amplifier circuit, so they can be used for as emergency broadcast amps as well. So you might, you know, fire alarms or whatever. If the power goes down, you can still keep supplying. They've got microphone inputs and stuff. You can still keep supplying audio throughout whatever it is and giving instructions, emergency drill, whatever. The usual, you know, buildings on fire, please vacate, not a good idea to stand still, that kind of thing. So there's the input board on here. I don't know if This looks to me as though it could do with that. So, yeah, maybe not. Who knows? Oh well, we're a bit washed out now. A little bit washed out in brightness. Yeah, we'll go back to that. So, this one's quite interesting on the input side. Let's zoom in. So there is there's like priority switching, there's actually an isolation transformer stuff in here. I think there's a direct like telephone, designed for a direct telephone line thing or something along those lines. There's a mix out, there's a monitor out, 1.8 ohm as well, so that's some kind of small, not entirely sure. Yeah, look, there's then settings on here for zone priority and the telephone volume. I'm guessing that's telephone. TRG will tell paging, so who knows, it probably uses some similar circuitry. I'm not an expert on that side of things. You've got, if we move it, so yeah, you really can't, black and white is not the best for the camera. So you got XLR input sockets, but they also have the standard 6.35 is it millimeter jack input. Run with his line mic or as a phantom powered. They were all set to phantom for some reason. And then the outputs. So yeah, there's not really a great deal more. Let's have a look at the front face. So yeah, individual. I'm guessing that. Crikey. So that must, if I was to guess without reading the instruction manual, which is probably what a lot of people have done, why so many of these have come back. So yeah, so this is your input. So you've got your, you basically have your 5 inputs. So you've got an individual gain control for each one of them. You can mix, so you decide how high the input is, just like on a mixing desk. You then got a basic EQ of just treble and bass, mute, and then a level control for each zone. So you basically would set the gain if you got, you don't want to like try and do all the gain here. You want a nice strong signal this end, and then this is your individual like mix control out of your preamp section, and then you've got your selectors here, so you decide which. So you could, if you wanted, send all 5 mixes into zone 1, and then that's a master control. So you'd have, you can monitor. This is quite a nice amp actually. It's like a miniature mixing desk in an amp, so that you've got monitor control and a headphone control. So you can individually select each input to what zones it goes into. You can mix it together at however levels you want throughout the mix. So you could have like yes, nuts that is, you can actually mix it. You could have multiple, I don't know why you want to do it like that, but you could have multiple different sources coming together. You know, it's handy for like mic and stuff. You're then going to set priorities and muting for mic and stuff. But yeah, and then you can individually set the level you want on each zone, and then like I said earlier, the people at those zones will generally have speakers that they can adjust the level on themselves as well. But so something in here has gone kaput. There's got to be at least 4 amplifiers in here driving the transformers, and something's gone up in smoke because it just keeps blowing. Oh, we've just got little like what are they, like LM3586 or something, a little gain clone package type amps. I just see a row of them. The camera's probably not going to see them. Try not to scratch the ass off my table. Let's see. Now we will. Let's wham the. So just there, and then yeah, on a big chunky heat sink, So yeah, that was a little look inside the, what is this? It's a Monacor something. The Monacor PA4040 4-zone PA mixing amplifier. So I suppose, I mean, seeing as it does have 4 ohm outputs, I suppose you could, if you was like a small pub or something, and you had, say, like microphone inputs and direct outs from people's guitars and stuff, you could actually mix them together direct in this amplifier and send them out. You know, you generally would use a mixing desk. I don't think that would be the best way of doing it, but it's doable. It's a very flexible piece of equipment, and it weighs, you know, 15 plus kilograms easily. Well, it's a shame. This, I have to say, it's got to be one of the most difficult amps I've ever taken apart. This bloody, it's like this is in multiple layers and there's wires going everywhere, and then there's this stupid like separator shield around the transformers you've got to take out. Yeah, I did quite a good recording of where everything went, because there's just lots of the same plugs of all the same coloured wires just absolutely everywhere. So anyway, I did a quick, the chips on this board are, you're not ever going to be able to see that, they are LM3886s. So did the usual. Normally when you're blowing fuses, as soon as you turn power on, it normally means shorted semiconductors. So just went over all the 3386s. No shorts on them between any rails or anything, no blown bridge rectifiers. Just thought, well, that's a bit odd. So what I was planning on doing is, because this is amazing how this thing's built. Can you see the symmetry here? There's literally 4 amplifiers all on one board. There's a tiny little fan control board in the middle here, but there's 4 identical amplifiers. Each one gets its own AC feed from the transformer. It's own rectifier capacitors, the lot. They're all separate, just sharing like a common, probably sharing a common 0V. You'd imagine so somewhere, otherwise you wouldn't be able to mix them all together unless you was doing it with transformer feeds and stuff. But anyway, no, it might well be, because the mixing's done at this point. So yeah, could well be the 0Vs could be completely separate throughout. Just I imagine they tie together on here, because I can't imagine this having multiple power supplies. But yeah, tie together on the front board, not that. But I got off on one there. So anyway, my plan was to apply the power, get the AC flowing through the transformer, and then my way along, see which one made the big arc and got hot, figure out which one was blowing, because statically they seemed fine. So all the secondaries of the transformer were unplugged, and I plugged it in, and there was just a loud, and everything went dead instantly. And I thought, well, seeing as there's no load on a transformer and that's just happened, there is only one thing that can be. And sure enough, so there's a dual secondary on this transformer. There's actually 5 wires for, well, primary, sorry, not secondary. There's 5 wires for the primary. You've got a fuse, you can bypass that if it blows and goes straight to the secondary primary end. Then you've got the yellow and black, and then the red. So red to, say, red to yellow is 115, black to grey is 115. So you put them in series, you get 230 volt on a 115 volt country, you'd parallel them up. Well, if I go across, I notice this meter sometimes, this camera doesn't like the click it makes. It's very obnoxious sounding. So if I go across the, so that's input to power switch, you can see straight away that's not the right kind of reading you expect for the primary winding of a power transformer. It should just be a couple of hundred ohms at max, really. So something's gone wrong there. Now if I come, sorry, nose is filling up again. So that's the live side. If I go into this point where they join, if the probe will stay in there, so you see 94 ohms on that side. So that's one side of the primary, and the switch is on. So that's going through the grey, so that's going through the grey side up to the black. So that's the grey black side. Is it grey black? It is grey and black. Yeah, so grey and black is one primary winding. I've just lost my probe again. So grey and black is reading at 94 ohms. If I go to the yellow and red winding, 1500 ohms. The winding has shorted inside. DC resistance, it's not seeing a lot, but somewhere in there when you apply 240 volts the insulation's breaking down, it's instantly blowing the fuses. So transformer on this is junk. There's no point trying to fix this, unfortunately, because each amplifier runs its own power supply. Now I could mess about, I could go and bolt in like a 24 volt supply and some other transformers for all the ancillary circuits. It's got multiple windings. What's this got on it? It's got some, so it's got multiple 18 volt, dual 18 volt windings for the amplifier supply. Then it's got a 13 volt winding. Yeah, so it's then got a 13 volt winding for something, and oh crikey, some more 18 volts, maybe a bit hard to read. It's tucked right down the way there and I can't really read it, but it's got multiple windings on it. So it'd be nice if it'd be nice to get it working, because it's an expensive piece of kit, and it is quite a piece of kit. It's one of those, it could be fixed, but realistically I've got that many others downstairs. By the time I've messed about sorting out the ones that are easy to fix, this thing's going to sit, it could be a year, 2 years, 3 years. It's going to sit for ages and do nothing. Bits will get lost, it'll get beaten up. It's a shame, really. I think more likely is probably just use it for a bitzer. Got a nice heat sink there. Use that, flog it, whatever. Got some LM33 36s. These must be like little, where are they? So what do they call those? Posistor? They're like little temperature dependent. So yeah, they're in line with the AC, and I think they're like a positive temperature coefficient resistor, but rather than one that has a gradual curve on it, they're almost 0 ohms. They're very, very low impedance, so they'll take quite a lot of current. They will only generate a small amount of heat. But however, as that heat starts going up and up, all of a sudden they just get to a threshold where they just rapidly, over the course of like a degree or so, they rapidly go to an incredibly high resistance state, and then they will never reset, because as long as they've got even a small amount of current trying to be drawn through them, they'll stay hot. So even if, like, say they got quite hot and flew up, as they start to cool down, instantly there'll be enough current trying to drawn to keep them hot enough to keep them in that state. And the only way to reset them is to remove power and reapply again. So yeah, they got them in each amplifier in line with the AC to, if there's a fault, it shuts the AC off to that amp. So yeah, that's a shame really, because it's a kind of a beast of an amplifier, but you know, I got some wideband audio transformers in here. It could be made to work at 115 volts. Well, it wouldn't be. It would only be running one primary, which would burn out pretty quick. And there's going to be something wrong with that transformer anyway. You don't use a transformer like that with a burnout primary, because that's going to have damaged other things. I've got this big ass connector block on the back end here. It's got some useful parts I can scavenge. It's a nice case, to be honest. I'll tell you what, it's a prime candidate for shoving something else in there at some point, because it is a big, sturdy, solid case. You've already got all these, you know, literally just apply power back to this and you've got a full mixing setup on the front end. Yeah, you can turn it into, could make quite a nice multi-channel amp. take these transformers out, you don't need to leave them in, you could just make it a direct 4-channel amp. So yeah, so I did, if you notice, I was going to sign that other video off if I don't edit that bit out, but I just decided, as it's knackered, I might as well film this bit of the video. Oh, I've got another frigging amplifier in bits. It's hard trying to store amplifiers in bits, they get in the way, they're just in the way. Right, so anyway, yeah, so that's the first one I'm going to say niet to. This one has "Sava techniczne problemy." Yes. I don't know the word for repairable in Russian, but yeah. So, dead. Dead as dead can be, shorted power transformer. Judging by the complete lack of dust and everything in here, I'm going to say it was shorted from the off. It's probably got, when they bolted it down or something, they've probably nipped one of the primaries and it's shorted out. It happens, it's a shame. I can't think what this one was to buy. It was, I think it was like 350 quid or something, or 400 quid to actually buy it new. It's a PA4040. It wasn't a cheap one anyway. Yeah, so anyway, joy of repairing stuff sometimes. It's like that Kenny, is it Kenny? Yeah, Kenny Rogers song, The Gambler. You've got to know when to hold them, know when to fold them. And this one just isn't worth messing with. Let it go. So yeah, anyway, thanks for watching and catch you next time.